All right, just started the recording here. Nate, you have your hand up. Do you have a question?
Yeah, I just would love, I have a few questions, but my output files for Gamut, to me look suspiciously good, and I can share my screen here really quick. So can you guys see my application?
Yep.
Okay, I can't click anything, which means it's working too hard in the background.
Okay.
Yeah, I basically I brought in 5 more days of data so I could get like a good GL red run, because it was hard to evaluate one data point in the output. So I guess maybe, oh, there we go. So we're looking for the Gamut output file. What folder is this in again, Mike? The log file?
Just the summary file?
Yeah.
Or it's called sh gamut and then the day number dot summary.
Okay. There we go. Okay, wow, this is actually really different. So my previous runs, my pre-fit normalized RMS were only about like 0.25, and my post-fit were slightly under 0.2. But it just seemed pretty high, or sorry, pretty low in terms of the pre-fit RMS, just like looking at everybody else's. But I guess I've added some more stations, and I think the overall the post. Oh yeah, so I added some more stations, and I think they added to a little bit more error. But does everything seem to look okay in here from your perspective?
Yeah, everything looks fine. I mean, you've got some updated coordinates there, but they were close enough that Gamut could use them, but not close enough that it really liked them. So it did a first run, a first iteration, and then updated the coordinates and did a second iteration with those coordinates that you see there labeled updated from LTEXP. So you could actually copy and paste those back into your APR file if you wanted.
Yeah, it's interesting because these are the ones that I took from the Rhinix file, because when I did the actual initial pre-processing, they were so far off it wouldn't run at all.
Right.
And so the other thing that I thought was a little suspicious is that the wide lanes fixed is 100%, and that seemed, to me this seemed suspiciously high. I don't know, just looking at everybody else's data.
Yeah. Are you processing a very small network, like just 10 kilometers?
Yeah, it's 4 stations and then like 4 or 5 UNAVCO and 4 or 5 IGS.
Yeah. Sometimes when the sites are very close together, a lot of the error effects, kind of cancel out a little bit more than they would over large baselines.
Yeah.
And so when you have very high quality data, as this should be for the modern era where you're using UNAVCO sites and things like that. If you have fairly short baselines, sometimes the algorithm is very successful at fixing those ambiguities. Yeah.
Cool. And then my next question is the VMF1 grids, which seem like probably one of the most important corrections to make. That's not a standard. That's not a standard in the standard site processing defaults. You have to actually physically go download them, and there's no way to automate that. You kind of have to do that beforehand. Is that correct?
Yeah, that's right. Because the grids are pretty large files,
Okay.
The default for the experiment is actually just to use an empirical model that
Okay.
approximates those grids.
Okay.
If people actually want to use the real grids, they would have to go, download the grids. And we talked about this in the vertical deformation and atmospheric parameters talk yesterday.
Yeah.
How to do this. That you would create a gg/grids directory, all in capital letters. You just download the grids there, and you switch on using the grids in the SESTBL file.
Yeah.
And then it will find the grids and it will run.
Yeah. Okay. I've looked around there. Sorry, it's a fire hose of information. So some things get.
Oh yeah, no, absolutely. Yeah, we covered a lot in 5 days. Yeah.
Okay, I am good for now, but hopefully I'll have a GL Red run done soon.
Okay, sounds good. Yeah. All right, so we have let's see, about 15 minutes here. I do want to get onto some demo stuff because I know that there's people in this breakout room who would like to actually just see the basic steps. So Parisa, you can ask a question, but then I'm going to move on to a demo very quickly.
Yeah, exactly. I wanted to, tell you that if it's possible, if we can see a demo of Globe K because it's really important. And so that's okay. I wanted to just say this one.
All right. Yeah.
Okay, thank you.
Okay. Yeah, so Nate, if you can stop sharing your screen there, and I will share my screen. Thank you. All right. So, well, this is what I did yesterday. It's only one day, but let's just run it anyway. So I have one day. This isn't going to be very interesting. You're not going to see any plots, and I'm going to do this the easy way. So the first thing that the test install did was it copied over some command files for globek and glorg. Again, what you'll find that I'm demonstrating here is really no different to what you already did in the test install. That test install example is pretty much a standard processing approach. So what you're going to see me doing here is really no different. But the first thing it did was copy over those commands. And so you can see here, copying globek.cmd and glorg.cmd from ggtables to the current directory, the current directory under the gsoln subdirectory. So those files are kind of standard. You don't really need, it is recording. You don't really need to edit too much about these, except under certain circumstances. But the one thing that I will need to check is what sites I included in my processing network. So here I included 5 IGS sites and some other ones, because these are the sites that are going to help me define the reference frame in the glorg module. So the thing I need to check is that these sites that I included are actually included in the list of stabilizing sites. So let's check that. COSO or P389 or Quinn or STFU or VNDP. Hopefully they are in the, well, there's 3 of them. There's 3 sites in this file here, which is the standard stabilization list for the glorg module. As you can see here, what we do is we source this file, and that means read everything in that file. And in that file is a bunch of these stab site lines that say, use that site as a reference frame stabilization. So we have 3 of the 5 sites in there, but we don't have P389 or STFU. So I'm actually going to add those because they should have pretty good coordinates. Just with a line like that. So I've just added 2 more sites to the list that I'm going to use. So I should have 5 sites to do the reference frame stabilization. Before I make that commitment, I do just want to check that they are actually in the standard APR file. And yes, that one seems to be in there. And that one seems to be in there as well. Okay, so we should have enough sites to do our stabilization. I'm just going to list them all. So that was a decision that we made at the very beginning, what other sites to include. And now you can see at the very end why that decision was so important. For most of you, I think you've been going through this process, and at least 2 or 3 of you have found that because you didn't include enough IGS sites, it was actually very difficult to do this stabilization. 5 sites should just about be enough. Remember, I did this very quickly. This was just a quick solution. I would encourage you to use more. But now we're just going to use SHGL-Red to do our make some time series. So,
Mike, can
yeah.
I make a question?
Yeah.
What if I have an IGS site near in my area, in my area of interest? For example, there is one in Santo Domingo City.
Mm-hmm. That's okay. You can just include it
as an stabilization site.
Yeah. The important thing about stabilization sites is that they have very, very well-known coordinates, and that they are available in the files that you write into your GlobeK command and GLOR command files. Okay. So as long as you fulfill those 2 criteria, the a priori coordinate is accurate and the a priori coordinate is available in the files that we read, then that can be used as a stabilization site, and that's no problem. Yeah.
Okay. Thanks.
All right. So I'm just going to do a single day here. Okay. Now, again, I am doing a demonstration here that is relative to my experiment. I want to reiterate, it's very important for you to not just copy what I am doing, but try to understand what I am doing and why. So in the test install example, you will have used this -S option because we were doing time series for 3 or 4 days. So we had a span of data. In my case, I'm only using 1 day of data, so I can just use this -D option. I could also use this with the same start and end time. But either way, just remember that I'm demonstrating something here. It's not a template necessarily, it's just giving you an idea of the sequence. All of the options that I use, you might want to choose something different for your own experiment depending on what you are doing. So I'm just going to use the -D option. It's 2022 day 1. My experiment is TGCG. And what else do we have here? We don't really need any of this. An earthquake file is already included in the GlobeK command file. Yeah, we're not going to get any time series anyway. I processed my network. Well, that's okay, that's fine. And what I want to do is, the first thing I want to do is convert my gamut H files into binary H files to read into GlobeK. So I'm going to add this H option to the options at the end. What else do I want to do? I want to run glred for creating, a final solution. And we won't run TS_sum because one data point is not going to produce a time series. So we can just run glred and see what happens. Okay, let's try that. All right, so what should have happened there is we have an H to GLB command up here that converts one type of H file to another type. And then we go into the glred combination there. You can see the command that was run. So my output file is going to be called this and then .org. Hopefully, no such file or directory. Okay, what happened there then? Okay, that's fine. All right, I'm not quite sure what happened there. Oh, no, it is there. Oh, I see. Sorry, I was in the wrong directory. This all takes place in the gsolution directory. Okay, so let's look at that. This is just one day, again, remember, but you'll see a similar output for all days. And at the top, we have this glorg output, which tells you a little bit about what it's doing with the reference frame stabilization. So there's 3 components of rotation, there's 3 components of translation, and we are using 5 sites to do this. This iterates a few times so that we get rid of bad sites and we change the weighting of all of the sites defining the reference frame depending on their quality. So by the end, when we get to iteration 4, we are still using 5 sites, so all 5 sites have been retained. You can see here that some sites have increased sigmas and some sites have decreased sigmas depending on their quality of the fit. And that should be our final, final stabilization. Then down here, we have some information about the beginning and the end of the solution. So again, this is just one day I'm doing here. The middle of the day is this time. We have some information about the models that were used, just so that we know what we did. We have a reference frame here. This is determined by the contents of the APR files that we used. And then we go a little further down. We have a copy of the globk command and the glorg command file that we used, and the a priori files that we used for globk and glorg, just so that we always have a record in the results file of what we did to produce these results. And here we see the summary of positions. This shows you the adjustment relative to the a priori coordinate. So these should ideally be quite small if the a priori coordinate was good. The sites that we used for our stabilization have a star here. So we have those 5 sites that we used for stabilization. The adjustments are all quite small. Some of the adjustments for my sites, TG02, for example, are a little large. So we could probably update our a priori coordinates, and we'll do that in a minute. The overall fit to the reference frame has horizontal weighted RMS misfits of about 2 millimeters, which is quite normal. and the mean offset is nearly 0. So this shows you a pretty good fit overall of the reference frame. Below that, we have these blocks of extensive information in a variety of different formats with the position information, the coordinate information. So you can see here, there's the Cartesian X, Y, Z coordinates, the final estimate, the adjustment, and the sigma. And here we have another coordinate system, just a local coordinate system with north, east, and up, rather than X, Y, and Z, and correlations between each of those positions. And that's just repeated for each site. That's basically the content of this org file. So if you run SHGL-Red, you will have one of these .org files for each day. Or if you run with the combination option, you will have one file that is combined for several days in a row. So it depends what options you used. For time series, we don't tend to use the combination option. For velocities or short-term combinations, like just over a week, we might use this option here. But again, this is why it's very difficult for us to do these demonstrations, because at this point, everyone is going to have a slightly different outcome that they are trying to do. Some people want time series, some people want velocities, some people want earthquake estimations. So yeah, this is why it's very difficult to do these demonstrations, because I can do a demonstration to get time series, but not everyone wants time series. So these options, I really encourage you to read through them, and that will give you a little bit of a better idea of what you might need to use in order to get to your ultimate goal. I will say, just we need to head into the break here. Tom or I, Tom and me, we don't use, Tom and I, we don't use SHGL-Red. We actually, when we do our Globe K stuff, we actually go in manually and do the sequence ourselves so that we can be much more careful with exactly what is contributing to our solution, what parameters we are estimating, and double checking everything. SHGL-Red is great for a standard solution using standard data when you just want time series and velocities. It's a little less useful if you want other parameters. And so, this is where it gets a little complicated, and we always hope that we reach this stage on Wednesday rather than Friday, so that we can go into those avenues and explore a little bit more. But unfortunately, we're on Friday now, and here we are. So yes, well, no. Let's be clear on this. Nate's asking a question there. I thought GL-Red doesn't do velocities. The program GL-Red, specifically the program GL-Red, runs the program Globe K once per session. So in that sense, GL-Red produces time series in a nominal sense. Globe K combines a set of data, a number of H files over a period of time, or even just H files on the same day. SHGL-Red, the script, is used to do either of those things. So what I ran here was SHGL-Red, which can run GL-Red the program, or it can run Globe K the program, depending on what you are doing. It gets a little confusing. If I was to use this NCOM solution here, it would run Globe K for a number of days.
And in theory, you can also, in SHGL-Red, if you have 5 years worth of data, you could actually structure the GDL file with plus signs against all of the values within 1 year, and then no plus sign on one, and then plus signs on all the ones below that. And then if you ran GLRed, it would actually take that first year of data and estimate velocities and positions from that, or you could set it up to do that. And you could do the second one. As Mike says, GLRed is just a quick shorthand way of taking a large GDL file and creating smaller ones, which are then passed into GlobeK. So GLRed itself computationally does nothing other than take GDL files and rearrange them into an order which you sort of specify by plus signs, or it can take them just one at a time if there's no plus signs in the GDL file. I think, as I said a few days ago, these days we probably would have done we would have done GLRed as a shell script rather than program.
Yeah, and so there is a question. We are on break now, and people are going to be coming back in 5 or 10 minutes. So I'm going to answer this question, and then we're going to take a break, and then we can come back for the final session. Please clarify what you imply or what you mean that you don't use GLRed but run it manually. Let me be clear. Tom and I do not use SHGLRed, the program SHGLRed, because when it comes to doing the GlobeK analysis, we like to be a little more careful checking the options that we are using, checking the H files that we are using, verifying that all of the sites are, where they need to be and things like that. And that requires you to go through a few more checking steps to be really confident of the fact that you have all of your options switched on. SHGLRed, you can do that, but you need to be very careful with how you set up your command files. SHGLRed is a quick way of doing a simple thing. When you want to do more complicated things, SHGLRed, it still works, but you need to be very careful what you're asking it to do.
Right. So we certainly use GLRed and GlobeK. We use them equally, and we use both of them. Okay.
Yeah.
So we're on break.
I don't know if that helps answer the question, but there is SHGLRed, which is a script. There is GLRed, which is a program to produce time series. And then there is GlobeK, which is a program to produce combinations and long-term velocities. We use GLRed and GlobeK. We don't tend to use the script SHGLRed. All right, I'm going to break it here, and we will come back in 15 minutes at 25 minutes past the hour, and then we will continue with our interactive sessions. Okay.
Good.
Thanks, everyone.